Hello guys, hope you all are doing well. So, in the continuation of the previous GATE series, we are solving questions of 1990s. So today we will solve 1997 section A. Okay. So very first question we have, without wasting time, we will solve the question because the exam is very near and I am a little bit uh, solving question a little bit delay and sorry for that. But hopefully we will solve all the subjective questions. Okay. So the very first question, this is the sum of infinite series. Those kind of questions is GATE not asking. Okay. So, but this is a kind of GP, geometric progression. So this question will not ask in the core that is in chemical engineering, but in aptitude it the GATE may ask. So you can solve this question. Okay, but I will not solve it here. Okay. So question 2. Limit x tend to infinity x cube plus 1 2x square plus 80 x plus 1. So if I will put the value x in infinity in place of x, then it will give infinite by infinite. And we know that when there is an infinite or 0 by 0 form, or infinite to the power 0 or infinite to the power 0, then we will apply L'Hospital rule. L'Hospital rule. Okay. So what is that? Differentiate numerator and denominator. So limit x tend to infinite, it will remain same. 3x square, 1 is 0 upon 4x plus 80, right? Again, if I will put x equal to infinite, it will give infinity by infinity form. So we will we will further do the differentiation of the numerator and denominator. It will give 3 to the 6 x upon 4. Now, if I will put x equal to infinity, then it will give the form of infinite by 4. So the answer is infinity. Okay. The value of the integral 0 to infinite 2 minus sin x dx. Okay. So it is 2 x infinite minus 0 minus differentiation of sin x is cos x. Sin x is equal to cos x dy dx of cos x is equal to minus sin x. So if I will take this dx here and if I will integrate this, then integration of sin x dx will be minus cos x. Okay, so here minus cos x 0 to infinite. So this is infinite minus cos infinite minus cos 0. So it will give infinite. Okay. Okay, next. Given that the function x square plus y square gradient square f. So very first gradient f we will see. So value of gradient is I del by del x plus j del by del y plus k. Third component is not there, that is z component, so we will not write into the function. Now the function x square plus y square, it will give I del by del x is 2x plus j del by del y is 2y. Okay, now again further it we will, if do the gradient of this, then it will give del square f. So I into I will be 1 into del by del x, that is 2, same 2, that answer is 4. Okay. When an unsaturated air water vapor mixture is heated at constant pressure, unsaturated air water vapor mixture. Okay, so very unsaturated means there is a high chance that the water vapor may go into the air. More water vapor can go into the air, but we are heating that at constant pressure. That means the relative humidity is the amount of the vapor present in the air. Since the air and water vapor mixture is unsaturated. If we will heat that, then the water vapor amount of water vapor will be less. So relative humidity will decrease. Okay. For the laminar flow of fluid in a circular radius, Hagen-Poiseuille equation, straightforward. Del P is equal to 32 mu u bar L by d square. But here is a trick. It is asking for the volumetric flow rate is proportional to. So 32 mu L by d square. What else is left? Velocity. Velocity is 4q upon pi d square. So q is directly proportional to d to the power 4. That is directly proportional to r to the power 4. So q is directly proportional to r to the power 4. Okay. In low Reynolds number, Stokes regime, drag force Fd is equal to 3 pi mu u bar d. So terminal velocity. The hydraulic diameter of annulus inner and outer radius Ri. We have solved these kind of questions, right? So suppose I have, this is Ri and this is R0, like this is R0, but just for, hope you understand R0. So diameter hydraulic is equal to 4 into hydraulic radius. This is R. Okay. So 4 into hydraulic radius is wetted area upon wetted perimeter. Wetted means the wetted by the fluid. The area where the fluid is touching the surface, the perimeter where the fluid is touching the surface. That's all. Remember this. So wetted area will be pi d naught square minus di square by 4, and wetted perimeter will be pi into d naught plus di. See, the fluid is in between the annulus, so it will touch this surface always, outside of the inner pipe and inside of the outer pipe. So perimeter will be the sum of the both diameter into pi d, that is the circumference, and area will be, because in this area the fluid is flowing, so pi d square by 4. Okay, but we have to take the area of the annulus, so pi d naught square minus di square. Now 4 will cancel out, pi will cancel, pi का हिसाब हो गया. So d naught square minus di square divided by d naught square minus d plus di square. Now you will a square minus b square formula. Okay, then replace d by r, so you will get this. Okay. Okay. For crushing a solid, Rittinger's law state that the work required for crushing proportional to new surface created. Straight statement. A reversible endothermic liquid phase reaction to be carried out in a plug flow reactor for minimum volume reactor at the high, since see, this is reversible endothermic RA at t equal to 0, RA at t is equal to at some time, RA at t is equal to infinite. So since it is reversible endothermic, we have to provide a minimum temperature so that the reaction will proceed. So temperature at the starting will be increased. Now at t equal to t sometime, when A will dissociate into B, since it is a reversible reaction, if we will decrease the T, then the B dissociate into A. So at T we have to increase the temperature. Now at T tend to infinite, that means we are providing the temperature, so the production of B will be maximized. That means to minimize the reactor volume, it is at highest allowable temperature. Okay, but the case is different for the exothermic reaction. Okay. A system undergoes change for a given initial state to given final state either by irreversible process or by reversible process. What could be the possible answers? Entropy change in irreversible always greater than the for reversible. We know that it is straightforward concept. The change in the Gibbs free energy for vaporization of pure substance is zero. Okay. A decomposition reaction in which A decomposes into B by the reaction to achieve the maximum conversion, desirable it is desirable to carry the reaction at C. A that gives B. The moles is not decreasing or neither increasing. The moles are same before the reaction, after the reaction. So very first thing, since it is a reversible exothermic reaction, it is a reversible reaction, but it is not exothermic. Okay. So reversible. Okay. So it is a reversible reaction, but it is not mentioning that it is exothermic or endothermic. So very first thing, the T should be low. T should be low or optimum. Optimum. That means the word optimum means the T should not be so high that it may go back to the reactant side. Okay. So low T will be preferable. Okay. Since the mole is same, low pressure is required. Okay. The number of the concept of moles decreasing, increasing is according to the Le Chatelier principle. Okay. Okay. Question 13. Two iron pipes of same nominal diameter. Nominal diameter means not exactly the inside diameter, but it is about inside diameter. Okay. But different schedule number. Okay. So answer of this question is the same outside diameter, but schedule number is important. Schedule number is equal to 1000 PS upon SS, where PS is the safe working pressure and SS is the safe working stress. Value of PS is 1000 upon SS. PS is 2 SS TM upon DM. So SS will cancel out. So schedule number depends upon the thickness of the pipe and mean thickness of the pipe and mean diameter of the pipe. Okay. So two pipe having the same inside diameter, but different schedule number. Schedule number is different. That means their thickness will be different. So same wall thickness will be same inside diameter will not be the answer, because same nominal diameter is exactly the same inside diameter, but it is on average. So the possible answer is same outside diameter. Okay. There is another number, that is SDR, standard dimension ratio, the ratio of diameter of pipe to thickness of pipe. Okay. In GATE 2016 there is Birmingham wire gauge number. We will see that later. Okay. So if we keep in mind this concept, the possible answer is same outside diameter. Okay. Okay. In distillation column, the number of bubble cap tray depends on the allowable gas velocity, feed composition, allowable gas and liquid. So this could not be the answer. Feed composition could be the answer, but in the distillation column, number of bubble cap trays depends on very first thing. Whenever there is an erection of a distillation column, the diameter of distillation column depends upon the gas velocity. How much quantity of the gas it can handle velocity. Okay, by studying the gas velocity and gas volumetric flow rate, the diameter of the distillation column is decided. Then when attaching bubble cap tray inside the column of distillation column, required downstream area. Downstream area is that area this area is called downstream area. Okay, this area is called downstream area, or there is some other word, downstream area, I think. Okay, so the number of bubble cap tray depends on the allowable gas velocity. Okay, downcomer area, I think, downcomer area. For shell and tube heat exchanger, with increase in the heat transfer area, purchase cost per unit heat transfer area decreases. Okay. The order of the function. So this is the graph. The graph cut in the x-axis. The number of times it cut in the x-axis is the order of the function. Okay. This question. Pure carbon is completely burnt in O2. The flue gas enlisted 70% CO2, 20% CO, and 10% O2. Percentage X is air, O2. Air is not there, so O2. Percentage X is O2 is equal to O2 fed minus O2 required, theoretically required, divided by O2 theoretically required. Theoretically required means required by the reaction. So you know that C plus O2, that gives CO2. C plus half O2, that gives CO. So CO2 is 70 kilomole, CO is 20 kilomole, and O is 10 kilomole, that is unreacted. So very first thing, total carbon reacted. Total carbon corresponding to which we are giving the oxygen. So total carbon will be 1 by 1 into 70 plus 1 by 1 into 20, 90 kilomole. This is 70 for reaction 1 and 20 for reaction 2. 90 kilomole will be the total carbon we are feeding. Corresponding to this quantity, based on the first equation, that is desirable, 90 kilomole of O2 we will fed. Okay. So O2 fed, sorry. This is the O2 theoretical required, which is corresponding to the stoichiometric. So 90 divided by the 90. Let's see how much O2 fed. So O2 reacted by reaction 1, 1 by 1 into 70 plus 0.5 by 1 into 20, 70 plus 10 is equal to 80. So O2 reacted by the reactions 80, O2 unreacted 10. So O2 fed will be O2 reacted plus unreacted, that is 90. So 90 into 100. So 0% excess air. Okay. If single pass conversion of A is 20%, single pass conversion of A is 20%, the recycle rate of recycle. Okay, so suppose this is M, A in M. Since we are only dealing with A, here we have A plus B, then B will go there and A will come here. So okay, 0.2 is equal to A in M minus A in exit of reactor upon reactor upon A in M. So 0.2 A in M is equal to A in M minus A in exit of reactor. So A in the exit of reactor is equal to 0.8 A in M. So suppose this is, if I suppose this R, so M is equal to 100 plus R. So the M is 100 plus, conversion is 20%. So here M in the exit of A in the exit of the reactor will be 0.800 plus R. This is the value of recycle only. So okay, that is A in M. So this is the value of recycle only. So R is equal to 80 plus 0.8 R. So 80 divided by 0.2 is equal to R. 400 kilomole per hour. ठीक है, 400 किलोमोल पर आवर. ओके. R. For laminar flow of a fluid through packed bed of sphere of diameter d, the pressure drop per unit length. C. Apply Argan equation for laminar flow. Very first, you write Argan equation. When you will apply Argan equation, then cancel the turbulent term. The remaining will be the laminar term, and depending upon that, depends on the diameter of 1 by d square. A suspension of glass beads in ethylene glycol has a hindered settling velocity 7.7 mm per second, while the this is hindered settling velocity. Oh, sorry, I have written twice. The hindered settling velocity is this, while the terminal settling velocity is this. Richardson-Zaki index is this void fraction. So we know that u settling upon u terminal is equal to e to the power n. U settling is equal to hindered settling velocity is 1.7 and terminal velocity is 17. Both are in mm per second, so you cancel out e to the power 4.5. So it will give e is equal to 1.7 divided by 17. 0.1. 0.6. So E is equal to 0.6. This 0.6. But this is the void fraction. What it is saying? Volume fraction of solid. Volume fraction is solid 1 minus E is equal to 0.4. Okay. Okay. I think there is no need to solve this question. It is at incipient fluidization by voided. You just apply this. Del P by L is equal to G1 minus E rho P minus rho F. That's all. Okay. For condensation of pure vapors, if heat transfer coefficient in film wise and drop wise are HF and HD, then HD. Drop wise heat transfer in drop wise always larger than the film wise. Always. Learn that. Okay. The gas phase reaction 2A that gives B is carried out in an isothermal PFR. The feed contains 80% A and 20% I. The XA is 0.5, then CA by C0. So C 2A that gives B, right? A 80% A and 20% I. So if I take 100% of feed, then 80 kilomole of A and 20 kilomole of E. So this is inert, this will not react. So this will remain as it is at the end of the reaction. So I will write 20I. But what is the value, what is the formula for expansion factor? Remember, volume at XA at full conversion. Volume at XA is equal to 0 conversion, volume at XA is equal to 0 conversion. See, conversion here is 0.5, but the formula for EA is full conversion. So we will find out at full conversion. So at full conversion, we will form 1 by 2 into 80. That is 40. So at the end 60, initial 100. So 60 minus 100 upon 100 is equal to minus 0.4. Okay, now CA by CA naught is equal to 1 minus XA 1 plus epsilon A XA. Put the value, you will get the answer. Okay. If you have any kind of confusion in these questions, just comment it below. I'll try to reply as soon as possible. Okay. Thank you guys. Bye.